Hello and welcome to another episode of Nathan Builds Robots. Today we have the Prusa MK4 in for review. You can see the name right there. And I'm really excited to have this machine in because, you know, this is kind of a higher end, more expensive machine. We don't usually have that on the channel. But fortunately I was able to meet Prusa at OpenSauce and he gave me a firm handshake and said, "Nathan, I'm going to send you a printer." So I gave him my details and here we are. Now we have a Prusa MK4. I warned him that I'm kind of a meme lord online. You know, I've said some things about Prusa printers that aren't the kindest. But he said, you know what? I'm bigger than that. I'm going to send you a printer anyways. So here we are. We have the MK4 and we're going to totally check it out. Now, as excited as I am to be able to review this printer, I should note that this is going to get the same classic NBR treatment that every other printer on the channel gets. That means I'm going to be hugely critical and I might end up taking parts off and replacing them. But in any case, it should be a pretty good time, so let's get on with the review. This was a pre-assembled unit, and then up top we have an exploded view of the extruder that's on this printer. But we're not here to review the box, we're here to review the printer. Now with every MK4 you get a couple accessories and you also get a bag of gummy bears. I'm not sure what this is about, but they've been doing this forever, so I guess it's a tradition of sorts. So it's well worth the premium to buy this over the competition because you get some candy. You get a spool of filament, so they provide you a full 1 kilogram spool. It's really nice to get a high quality spool of filament to get started with your printer. Also, this gives Prusa an opportunity to show off their Prusament. That's their own branded line of filament that they make in-house. I've used this stuff before and it's very high quality. Each spool is packed and sealed, and all of the filament is laid up extremely neatly. They've also got a bunch of really nice colors, and it's just a really good, consistent filament. The only thing that keeps me from buying it regularly is the pricing. But anyways, it looks like they hooked me up with a little bit of extra filament here. There's a bunch of extra data about this exact spool of filament, which is really neat. They provide an exact weight of the filament. This is a 1 kilogram spool, but they actually overpacked it by 7%. So there's 1,074 grams of filament on here. So you get a little extra. Also, they provide a plot of the filament diameter over the entire length of the spool. So that's letting you know from start to finish exactly how wide that filament is. What most filament manufacturers will do is they'll tell you the filament and then plus or minus a certain dimension, and you call that the tolerance of the filament. Well, Prusa is telling you that this is plus or minus 0.01 millimeters, and they're also providing you the data that you need to verify that that claim is true. So that's really cool to see. That extra level of precision and craftsmanship is why you might want to get some Prusament over the competition. Oh, this one is actually plus or minus 0.011 millimeters. So this one is slightly less precise than our spool over here. But regardless, that's still really cool that they're able to hold such close tolerances and provide such high quality filament. Most other filaments on the market either don't provide the tolerance range for their filament diameter, so you don't know how far off it is from 1.75. And some will provide the tolerance range, but it's a wider tolerance than what you get with Prusament. So this is some Sovol filament, and they're saying it's a 99% probability of plus or minus 0.03 millimeters. So that's 3 times the variance in terms of how far off this filament could be. So you're looking at about 2% variance on this filament, and something like 0.6 or 0.7% variance on the Prusament. Now you might be wondering why such a small difference even matters. Well, when you're looking at engineering material properties, you want things to be very reliable and consistent, and if you have one batch of filament that's slightly under extruded, and then your layers aren't going down correctly and bonding as strongly as they should be, well, that's going to affect your material properties and make that filament either stronger or weaker than it should be. There's all sorts of safety critical applications where you don't want things to fail, or just in general you want things to be as reliable as possible. And that really has to start with having reliable filament. If you're under extruding by 2 or 3%, that can really affect the interlayer bonding and really affect part strength. So having the consistent material properties that are documented with data is something that is really nice, and it's just more professional. Also in the box you have this test sheet that's like a receipt of all the quality control that they did on this printer, verifying that they've been tested and they're functioning from the factory. On top of that, you have a printed object on the print bed, so they actually ran this printer and made sure that it works before they sent it out. So that extra little bit of professionalism and quality control is why you might consider something like a Prusa. This one came with a couple of extra PEI sheets. This is a steel sheet that's textured. This is a steel sheet with a satin finish. Both of these are double-sided, and the one that's already on the printer is also double-sided. So you've got a lot of different print surfaces, which is nice because if you want to mass produce things, then as soon as this is done, you can just pull this off, put the next one on, and fire up the next job instead of rushing the process and potentially damaging the plate. That's something that happens on a lot of my print beds. I'm like, all right, I want to start the next job, so I'll be really chiseling at it to get the part off, maybe not taking all the time that I should to get it off properly, and then I end up damaging the print surface. Well, by getting extra print surfaces, you kind of protect yourself from making those kind of stupid mistakes. You can take your time making sure you remove the parts properly. Let's put all of that away, including my spare gummy bears. Alright, so let's just take a look around this machine. It's a new design. I've used the MK3 and MK2s in the past. I actually bought a couple of MK3s at my previous job because it was one of the best options on the market. Now, given in the 2 years since I made that purchasing decision at my previous job, there have been a lot more plug-and-play options coming to the market. But nonetheless, I think you get a level of support with Prusa products that you don't get with a lot of other manufacturers. Looking at the details of this machine, they've made a lot of changes. So one of the complaints I've had about Prusas in the past is their over-reliance on 3D printed parts. But I'm noticing on this printer, they're actually using a lot of injection molded and stamped sheet metal. And even this large frame on the previous iterations of the design, I believe it was laser cut or water jet out of a large piece of aluminum. On this one, it's die cast. So you can see this hexagonal pattern in the back and these little tooling indentations. This indicates to me that this was die cast. So they're investing in tooling, trying to make their production a little bit cheaper and improve the quality, reduce weight, and material usage. These two electronics boxes on the back are metal, so they're both folded sheet metal. You've got the power supply on this side and the control board on the other side. Looking at all these cables, these are very well wrapped cables. You're not going to have any issues with the cable management here, rubbing against things or getting in the way of your prints. It's just a really professional job there. Another notable upgrade on this MK4 over the previous iterations of the Prusa MK machines is they're using much larger diameter steel rods on this Z-axis, and I assume that was necessary to get the reliability they needed for high-speed printing. Those thicker beams are going to be stronger and resist deformation, so that'll help with printing precision and accuracy when you're moving at higher speeds. All of the linear motion components on this machine are linear rods with linear bearings. There's no bushings, there's no linear guide rails, there's no V-groove wheels. They just decided, you know what, linear rods are kind of the optimal solution, so we're just going to standardize around that. We've got dual Z-axis lead screws here. Now there's some cheap knockoffs of this machine. The main one that comes to mind is the Soval SV06. It's basically like a cross between this and an Ender 3 printer. But I will note that the linear motion components, these linear rods, are of much higher quality on this machine than they were on the SV06. So you're not just paying for the name, you're paying for higher end components that are just going to be nicer, they're going to run smoother and probably last longer as well. All of the motion on this machine is really smooth. There's little to no binding and everything moves really well, and you're not hearing any like random scraping noises like you might have if you're using cheaper linear rods or linear bearings. So that just further adds to the professionalism and reliability that these machines are known for. Now this machine also has its fair share of plastic 3D printed parts. And Prusa manufactures those 3D printed parts in-house using their own in-house filament. They say this lets them iterate through their design and produce parts and test their printers thoroughly before releasing them. And I tend to agree with that. I think it is a little more expensive than just investing in injection molding and cranking out a bunch of parts at lower cost. But, at the end of the day, that's part of their motto and part of their company ethos. So, that's just a decision that they wanted to make and they're running with it. And it seems to be working all right for them. And there are some things they could do to get the price of this machine down. For one, they could switch to injection molded components for all of these 3D printed plastic parts. That's just going to be cheaper to mass produce, but they're sticking with their in-house print farm approach. Also, they could use lower quality linear bearings and linear rails. But then, you're sacrificing quality, and at the end of the day, that's not the experience that Prusa wants to provide. They want to provide a high-quality machine that you can count on. That starts with having high-quality components and using high-quality filament. Other than that, this is pretty much a standard bed slinger design, but let's get this plugged in and power it up and see what all the hype is about. So we've got this plugged in. Let's flip the little power switch back here and see what happens. And we're getting right into the setup here. So you got to select your language. I'm going to pick English. This isn't a touch screen, is it? Something I'll note is usually I'll have to dim the lights in my studio because I have an extremely bright like filming setup just to get the best image quality. But on this machine, even with my stage lights on, we can clearly see what's on this screen. So they're using a nice low glare screen with nice brightness and contrast, so we can read it without having to mess around. So there's Prusa. He's giving me a little wink. Okay, so it's going to do its self-test, and it's just going through each individual item and kind of making sure the printer works. All right, load self-test. You'll be asked to tap the nozzle. Don't worry, it's going to be cold. Okay. Oh, is this a touch screen? I don't know. Tap the nozzle on beep. You did not tap the nozzle, or you tapped it too soon. Retry. Okay. Okay. Ooh. Ah, it's doing this little thing where it goes up to the top of the printer to align both of those motors. I think what's happening here is it's tuning its bump detection. So it uses sensorless homing, and it's just making sure that those parameters are set up correctly. So it's like repeatedly bumping into the bed and trying to figure out what should that be set to detect that bump reliably. It does look like it's kind of spazzing out a little bit though. Kind of funny to watch. All right, now time for the Z-axis. Wow, and the nozzle is going to go all the way up to 290 Celsius, and the bed is going to go all the way up to 110 Celsius. So it's doing a full temperature range test. Now I assume they tested everything at the factory, but it's important to retest it when it gets to its final destination, just in case anything got bumped during shipping. Okay, so it looks like the self-test is complete. Happy printing. Alright, I want to print something, but this printer needs a USB stick to be installed to be able to print off of it. You've just got the one USB Type A port on the right side up there. Around back there's a USB Type C port and an Ethernet port. So if you needed to use those, they're back there. I'm going to remove this factory print and we'll go ahead and start up the spatula. It's saying, warning, filament not detected. Please load filament. Ooh, that was a nice noise. Let's take a look at this Prusament. Look at this. Extreme consistency. Loading filament. Make sure the filament is inserted through the sensor. So I'll insert it up here at the top. Then hit continue. And that's all loaded correctly. We'll hit yes. And now it should get started with the print job. Cool, we've got some little status color LEDs at the bottom here. We love to see it. While this thing is running, I'm going to check out PrusaSlicer and see what kind of options they have in there for running my MK4. I already have it installed on my computer because that's my slicer of choice. I might switch over to PrusaSlicer at some point, but you know, I just like the simplicity of PrusaSlicer. Alright, we've got our spool is so loaded right now that it's popping off a little bit. Maybe I do want that little spool guide add-on. I assume they provided it for a reason, so how do I attach this? Nozzle cleaning failed. Well, let's retry. Oh, okay. What? If you pull up on this filament... Okay, so if you pull up on the filament, it actually detects that as the nozzle touching the bed, just because of the way that their load cell is set up. So I clearly messed something up there. I was probably doing something dumb. But fortunately it was able to detect that something was wrong, and now it's printing away just fine. Okay, so now it's doing some mesh bed leveling or something. Just get that installed over here. So it detected that the filament had run out because I was doing stuff. So it automatically went over and parked and retracted this thing, so I'll just pull that out. And I'll put the new filament in. It's the same filament, it's just I wanted to run it through this little guide thing. So we're just getting that installed. We'll plug that in there. Then hit filament unload successful, yes. Changing filament. Please remove filament from sensor. And then insert it. Press continue and push filament into the extruder. Okay, there you go. So just like that, we're back up and running. So filament changeovers are pretty simple. It's going to purge a little bit. I wonder if I have to manually clean that off or if it takes care of itself. It says color is correct, yes. I guess this would be a good opportunity to just like clean this off the nozzle and hit yes. And it's going to continue printing. But there's some more plastic that I missed out on. Well, that's a relatively seamless color change. It's not perfect though, because you can see I ended up with a little bit of a booger hanging off there. But that's not that big a deal. I can clean that up. Now I'll do the same decibel test that I do on all printers. We'll measure it from an arm's length away. This is really weird. It's oscillating between 38 decibels and 46. I assume the noise is basically what's being generated by these stepper motors. Okay, and now we're starting the next layer, so I guess it's going to turn this cooling fan on now, and it's moving a little bit faster, so let's redo that temperature measurement. We'll be arm's length away just as always, and let's see what we got. Wow, it's like 41 to 54. That's a huge range in noise levels, and it has entirely to do with the travel moves that the machine is making. But overall at baseline, the machine is very quiet because they've installed silent fans on here. And I can't tell you how much of a fan I am of that. So yeah, this motion system seems to be generating a majority of the noise. Alright, so right now the microphone is attached to the camera, so you can hear kind of what it sounds like from a meter away. I mean, this thing is handling this high-speed print quite well. It's got 7 minutes left according to its internal calculator, so it's going quite fast. Alright, and while that print is going, I'm going to fire up PrusaSlicer. This slicer is really simple to use and it's very snappy, so that's why I always like using PrusaSlicer. I've been using it despite not having a Prusa 3D printer because it's just the slicer I prefer to use. But now I'll finally be able to use the profiles that are built into this machine for the MK4. We can see our Prusa MK4 with input shaper, so we'll check that and we'll check that. And we'll go ahead and slice it. I mean, I'll just leave it at this kind of default speed profile. There's also the structural profile, which I assume just adds a couple extra perimeter layers. But one of my favorite things about PrusaSlicer is when I was deciding what slicer to use, there's basically this or Cura. And with Cura, there was some models where I would click the button to slice it, and I'm not even kidding, it would take like 20 minutes to slice. In PrusaSlicer, everything is always super snappy, so watch this. Click. Slicing. Done slicing. I'm actually going to cheat a little bit and rotate this model just so that the overhang is facing towards the fan as it's being printed. So this will be kind of a best case scenario for overhangs. And then we'll reslice it. So it's saying this whole print job is going to take 3 hours and 38 minutes. That is quite fast. If we switch this over to the non-input shaper version, curious what the difference in terms of print speed is. So it's saying without input shaper this would take a little over 6 hours, but with input shaper it almost cuts the time in half to 3 hours and 38 minutes. There is an option to set this printer up on Wi-Fi. It's got a little Wi-Fi chip, and then I could, you know, do the whole wireless transfer thing, which I'm really interested in doing because that sounds really nice and convenient. But in the meantime, we've got our Prusa going over here with input shaper. It's printing quite fast, and the print quality looks fantastic. Okay, and we're done. Let's take this off. Then, you know, flexible PEI sheet. We've all seen this trick before. Ta-da! So let's put this back on. Interestingly enough, the Prusa didn't even prompt us to set up our Wi-Fi. This is in stark contrast to some other brands that really want you on their cloud. To that I say, I don't want the cloud. Print finished. Let's go home and set up the Wi-Fi. So settings, network, Wi-Fi, set up a Wi-Fi module. Use the online guide to set up your Wi-Fi. Huh? Wi-Fi ESP module firmware update. What? I don't know what this is. Okay, I think I read about this online. Apparently you have to enter your Wi-Fi password onto the dongle. I don't have a USB-C to USB-A adapter, and I'm on a MacBook, which is clearly the superior, thing. But there's just one thing about MacBooks, that they don't have USB-A ports. Wait, there's one. There we go. That's what we need. A little USB-C to USB-A adapter. All right. So with that, I guess I'm going to have to figure out how to set up the Wi-Fi on this thing. The setup seems a little annoying. And of course there's the Ethernet port, so you could just plug this directly into your router if you wanted to. But I want to get the wireless working, so let's do that. Set up Wi-Fi module. I have to scan that thing. That opens up a website. PrusaLink. Set up introduction, so blah blah blah. Editing the configuration file. Here we'll generate a prusa.ini configuration file on the USB drive. Okay, we gotta plug this in here. Create credentials. Yes, remove the drive. Edit the file on your PC. Okay, so now I have to plug this into my computer. We have to edit this ini file, so I have to open with, I guess, Notepad. Oh shit, no, this is, man, I hate this. In order to run Windows files on my computer, I installed this other program and it always wants to open up whenever I double click things. Okay, so let's see. Open with Other, Text Edit. It's like a special program that you need on Mac to be able to open text files. It's completely ridiculous. Okay, and then right here I have to type in my Wi-Fi, SSID, and password. So fortunately, I know that by heart. I have it memorized, so I'll just type it in now. But no, I'm not going to show you, so cover your eyes. Then we'll save that. Now that we're done editing this file, we'll pull it out, plug it back into the printer, plug it back into the printer over here, set up Wi-Fi module. So it's updating the Wi-Fi stuff. This will take maybe a couple of seconds. Okay, so config detected on USB drive, overwrite current file, yes, I guess. Okay, remove the file, remove the drive. Make sure the USB drive with config file is connected. Continue to upload settings to the printer. Okay, so I did this incorrectly somehow. I have to enter that password in again. Uploading config to printer. Success. Please wait until the connection is established. If nothing happens after 5 to 8 minutes, check and load your credentials again. Okay. Oh wow, there's my username and password. I probably want to change that. Yeah, I don't know the difference between PrusaLink and PrusaConnect. I guess one is for like if you have one printer, and the other is if you have a bunch of printers. Can I connect to it on PrusaSlicer yet? Anyone? So there's this whole process here that I need to follow. So I need to get the IP address of my printer, then open up a web browser on my computer. Settings, network, IP address. I need to enter that on my computer. So now here's PrusaLink. So now I've got PrusaLink. So I'll just save this in my printer UIs. Now the real question is, can I run PrusaSlicer and just automatically have it send G-code? And I'm concerned that the answer is no. It's not really, I mean, there might be some way to set this up that I don't know of. Okay, it says, great, you made it. You can now delete the configuration file from USB drive for security reasons. So since you put your wireless SSID and password on there, you're going to want to delete that off of the flash drive so you don't just have a copy of that floating around. Now you may want to add the printer to PrusaConnect to be able to control the printer from the internet using the PrusaConnect cloud service. Yeah, I probably don't want to do that. I'm not a big fan of clouds, so. Now I'm just going to leave this flash drive connected to this machine because I'm pretty sure it needs some kind of storage to temporarily store the G-code files on there. But I should have the rudimentary workflow set up now. I'm going to go into PrusaSlicer, so that's just saved on my computer. And then I can go to PrusaLink, and then I can upload that G-code. I don't know if this is normal. This seems a little slow. Let's look at the local storage Here I can see all the files that are on that flash drive. This is the file that's being uploaded now. And it's just kind of taken a while, you know? It's a little bit slow, but that's okay. So I'm going to go do something else for about a minute while this finishes up. All right, there we go. It's done. It only took, I don't know, about 1 or 2 minutes. Kind of annoying that it took that long, but we'll let it slide this time. All right, is the printer ready? Is the printing sheet empty and clean? Well, as you can see, it is very empty and clean right now. So let's go ahead and get this print started. And just like that, we've started the print over Wi-Fi, so that's pretty cool. Now you can always do the old-fashioned, you know, take the flash drive out, plug it into your computer, upload your G-code, and then plug it back in and get it started. I mean, there's always that workflow, which is probably going to be a little bit faster on this printer because of the speed of that Wi-Fi module. But hey, we got this thing printing. I'm really curious to see what kind of print quality we can get out of this thing. I'm expecting very good print quality because, you know, Prusa machines, they charge a premium for their perceived quality. But let's see if that translates into tangible print quality. Tangible print quality. Okay, so let's meet back in, what is it, 4 hours when this is done? 3 hours and 37 minutes. Now, this machine is pretty quiet when nothing's moving. It's just those motion systems generate a wee bit of noise. Just watch this first layer go down. It's pretty entertaining. This is what we live for. 3D printer content. So why don't you guys watch this for a while? I'm gonna go somewhere else because, I don't know, I just don't like watching printers work anymore. They bore me. But you might find this entertaining, so go ahead and watch. Actually, you've seen this all before. I'm just going to switch it into time-lapse mode and we'll watch this thing just get printed real fast. Alright, so I'm starting up another print job here. You can see I've got the non-input shaper profile selected on this slicer. So this is going to print in a little over 2 hours, versus on the input shaper profile this would print out in a little over an hour. But I'm curious to see what the quality trade-off is. So if you're printing with input shaper on, obviously it's going to print a little bit faster. But if you're printing with input shaper off, things are going to print a little bit slower, but you might get higher quality. So we're going to investigate that. One of the things I really like about the Prusa ecosystem, if you're using all of their products, is that it's really easy to break your parts free. You just flex it a little bit and the parts pop right off. Also, when uploading this print job, it only took about 30 seconds using this PrusaLink software where I'm uploading it over my Wi-Fi. Obviously, if I'm just printing this out, it's going to be a smaller G-code file than printing all 4 of these items out. So it ended up being able to send the file over in about a quarter of the time. Much faster uploads there. If you're printing out small items with shorter G-code files, then it's probably not going to be an issue in terms of how long you have to wait. But if you're printing a larger object or build plate out that's going to require hundreds of megabytes of G-code, then it's probably going to make more sense to just unplug the flash drive, plug it into your computer, and upload it that way, rather than using the Wi-Fi based file transfer. Alright, and for my final print of this review, I've got this Robo Llama that I printed out. So let me break this free. Alright, now let's take a closer look at all of these prints. Starting with the first print that I did, this is the spatula thingy, and this looks really good. If you look really close, you might notice there's some little bits of under extrusion on the top layer, but overall, a much better result than most 3D printers that I have. There's a little bit of filament missing here because there was like a piece of gunk stuck to the hot end before it got started, and that got deposited there. But other than that, this bottom layer looks flawless. Just look at it. It's pretty nice. These layers on the side look really good. Overall, quite nice result. You can see just a tiny bit of under extrusion. There's a little bit of gaps in between the layers there. And maybe if we turned up the flow multiplier a little bit, we could get that to close, but overall it's still a nice functional part, and it's nice and strong. Alright, and if we take a look at this benchy, overall it's a very good result. There's just a little bit of curling there up on the bow, but looking at the rest of it, it looks quite good. You know, it's kind of a dark filament, so we can't see everything going on here, but yeah, back here you can see some insufficient cooling as well. And let's see what else we've got. On the top, everything looks pretty good. Overall, a good result. It's just for the steepest overhangs, there's a little bit of insufficient cooling. Then we've got our two mechanical parts. These are fan ducts that I designed for an Ender 3 mod. This was a really fun mod to design. I used a lot of tricks here to make these super easy to print. But one of the things that I really like about the print surface that they use, this smooth PEI sheet, is that it's super flat, so if you have pieces that need to be glued or bolted together, they fit together pretty much perfectly. There's like no gap in between these parts. And if you just used a tiny bit of super glue, you could get these stuck together very well. I just printed these parts out on the CR10 SE. That's Creality's latest Ender 3 style printer, and as you can see, the quality on this one is a little bit lacking, but on the Prusa model, these layers are stacked perfectly. This looks very good. You can see how consistent these layers are stacked, and that's just going to lead to a much more reliable printing experience because it's laying things down much more accurately and precisely. If we look at this model from the CR10 SE, you can see there's like a lot of inconsistencies here that are really highlighted by this harsh lighting. Also, you can see some ghosting there. But on this Prusa MK4, you have near perfect print quality. I guess the only real downside of this printer where it falls a little bit short is the part cooling, and we'll get a better look at that on these models. On models that are well designed to be printable, like these ones that I designed myself, I never exceed a 45-degree overhang, so most printers can do a pretty good job at printing this, even if they don't have the best part cooling. But overall, everything on this print is super clean. There's a tiny bit of under extrusion right here. See this layer I can peel off. There's a little bit of a gap. And I think what's going on here is Prusa has implemented input shaping, so they're able to print things a little bit faster. But they need to also implement flow calibration. So basically, you know, pressure advance and that kind of stuff. They might have some basic implementation on here, but you know, as you speed up the printer, you're also going to need to improve the extrusion quality, and part of that means tuning the flow calibration. But I think what's happening is the printer stops and then it comes over here to start this line up, and the nozzle has to be primed by running a little bit before it's fully extruding, and that's why you have a little under extrusion here. If it bothers you, you can either turn up the flow rates or do some kind of flow calibration, or just slow the printer down a little bit for those perimeter layers, or maybe a little bit of prime on restart. So there's a lot of things that you can do there to fix those minor issues. But overall, the core motion system of this machine is very good, and it's able to stack these layers one on top of another with a very fine degree of precision. Once again, compare that to something like the CR10 SE. It's got some issues with vibration and inconsistent layers. That's a very good result on this Prusa MK4. Now, let's set these aside and take a look at these calibration prints. I want to see if you can figure out which one of these was printed with input shaping and which one was printed without input shaping. So one of these took about 3.5 hours to print, and the other took about 2 hours to print. We'll start with the one on the left. So just check this out. Does the flow look well calibrated? Are the perimeters nice and smooth? Is the part cooling keeping up? All right, and then let's look at this one on the right. How's the part cooling? How are those perimeters? How's the bridging and the flow calibration? All right, well, here's the big reveal. The one on the right is printed without input shaping. The one on the left is printed with the input shaping profile. Overall, they both turned out really good. I will say the non-input shaping profile does look a little bit better. And part of that is because the print head is moving a little bit slower. It has more time for that filament to be extruded out nice and smoothly. You can see a little bit of ringing as it rounds the corners, but overall, really not bad. In terms of overhanging performance, it looks like it does a good job all the way up until this part right here, which is 50 degrees. At 60 degrees, we start seeing some drooping, and then 70 and 80, some more severe drooping. I'd be very happy with prints that come out like this. Let's take a look at the input shaping profile. So one of the main things that I'm noticing is right here on this little tower. If you look at this edgewise, you can see it kind of has these weird artifacts, and those are lined up with the top of the numbers there. So I think what's happening is it has to slow down a little bit for printing these numbers, and then when it gets to those long straight sections, it's building up more speed and it's overshooting a little bit. So that's enough of a ledge to catch my fingernail on. And I mean, that's not amazing print quality, let's be honest. But overall, it is still quite good. And it's really only on synthetic tests like this where those kind of issues show up. On these other models that I printed, there really wasn't any issues with the input shaper profile. And on the Benchy, as well as this big Robo Llama model that came pre-sliced on the machine, the input shaper profile did a quite good job at recreating all of these features and making a nice clean print. I think any of the issues that crop up from the input shaper profile have to do with the increased print speeds, so the part cooling can't quite keep up with it. But I also will mention that on both of these overhang towers, we have one corner where there was just a tiny bit of droopage going on there. It happened on this one as well as the other one. And that was the far edge. That was far away from the fan. So it was printing in this orientation, and you have the fan blowing air like this, kind of diagonally across the front, and that back edge wasn't getting cooled as well as the front edge here. So it's kind of an interesting choice by Prusa to use this type of cooling setup. This is a pretty small part cooling fan, and it's not quite as good at cooling things as a really large part cooling fan, like a 5015 that I use on most of my Ender 3s that are modded. But it does a pretty good job, and it just means you have to slow down a little bit to get the best print quality on it. About this tool head, we'll do a little bit of a deep dive onto this maybe in another episode, but it's pretty interesting how they have this so it can just pivot out of the way here. I think I might design my own part cooling system that can just kind of drop into this existing solution. That would be pretty cool to just have another part that you can take this one off and put a new one on and get better part cooling, because that does appear to be a weak point on this machine. It's not the worst part cooling I've ever seen, but on a machine at this price point, it should have amazing part cooling. I think where the MK4 really stands out is in the overall build quality, the reliability, and the motion system itself is one of the nicest motion systems on a 3D printer that I've used. This frame is incredibly stiff and very reliable and repeatable as it's laying plastic down. You know, when it prints an outline and then moves up to the next layer and prints the outline over again, those layers stack up exactly on top of each other because they've just done a really good job making a solid frame here. Also, the extrusion seemed quite consistent coming out of this machine. The only areas where I noticed there was issues is there's some areas where there's a little bit of under extrusion on these perimeter layers, and I'm guessing that they need to implement some type of flow calibration to take care of that. What's really interesting about how these pieces just fit together and are super flat is it just goes to show the dimensional stability you get off of these Prusa machines. These are just like, you know, it's almost like two machined plates sitting next to each other. They just are perfectly mated together like this, super flat and consistent. If we compare that to what I've printed on another machine here, this was printed on the Creality CR10 SE. You can see like these don't fit together quite as well, and just looking there you can see a gap in between these pieces. In fact, I think you can see a little bit of light through there. Alright, so we've done some prints on this machine. We've taken a close look at the print quality. You know, it's not as perfect as I thought it would be. They definitely need to increase the part cooling a little bit, and they might need a tiny bit of flow calibration to get the most reliable perimeter layers so that they're always like right next to each other and perfectly extruded. But overall, the prints that I'm getting off of this machine are extremely good. It's definitely in the top 5 to 10 percentile of 3D printers. The only caveat there is the part cooling solution. I feel like they definitely need to put a slightly bigger fan on here. I understand that having a smaller fan is more convenient and it's quieter, but nothing beats having dual fans or maybe a more powerful fan setup just to get better print quality when you're making overhanging features. So why would you want to get this machine over the other printers on the market? Well, to answer that question, I'll share my experience of buying a couple of these machines at one of my previous jobs. Basically, we needed a 3D printer to produce custom tooling on a manufacturing assembly line, and I needed something that was just reliable and would work. We had another 3D printer in the shop, but it was constantly having issues that needed to be fixed, and it wasn't the type of printer where I felt like I could just fire it up and let it run overnight and be pretty certain that I'd have my parts ready for me the next morning. The other printer in question was a Creality CR10 V3 or something, but it was a 300 by 300 build area, Bowden tube Creality printer. And what I really liked about the idea of getting a Prusa is they just do a really good job of supporting their customers and making a solid product. Now, these aren't perfect machines and they do have issues every now and then, but the issues that I had when I was running two of these professionally were few and far between. I had those printers running constantly for the 3 months that I was there, and I had two issues. One was the smooth PEI sheet kind of coming undone. I was printing a lot of PETG on there, and it adhered a little bit too good to that print bed, and over time of repeatedly breaking models off of it, eventually I had little pieces of it bubbling up and peeling off. And the solution for that is to just print PETG on the textured steel sheet and print PLA on the smooth sheet. And also I've learned there's some things you can do to help repair issues on the sheets before they completely break down. Like you can heat it up and press those bubbles back down. So, that was probably lack of maintenance on my part. I was cranking out hundreds of these little electronics enclosures. So, that repeated stress of breaking it free in the same places on that PETG was starting to cause issues. After the smooth PEI sheet broke down, I switched it to the textured PEI sheet, and I had no issues after that. The other issue that I had was a clogged nozzle. I'm not sure exactly what happened, but it was one of those cases where I fired the printer up and left for the evening, and it built up a blob on the nozzle and unscrewed itself, and then started leaking in the heat break area. And it just made the blob of death where it just has a bunch of plastic buildup on the hot end, and it just kind of engulfs the wires and the hot end and all sorts of stuff. So that wasn't a great experience. Someone else was trying to fix it before I got into work that morning, and they cut a bunch of wires off of the thing, and I had to buy replacement parts for it. But I think I could have fixed it by just being patient and reprinting the fan shroud, and I probably could have reused the old hot end by just patiently prying the plastic gunk off of it. I think overall the better solution was to just get a new hot end and throw that on there. Some of the plastic parts of the carriage were damaged, but I was able to reprint that out and reinstall it. It took maybe 2 hours to disassemble the old hot end and put it together with the new part, which was a little time consuming, but overall those type of issues didn't crop up all that often. But altogether, for putting them through that much work, having two small issues is not that big of a deal. Also, that was the older version of this machine, the MK4S, so for what it's worth, maybe they've fixed those issues on this machine. One of the concerning things with the Prusa lineup is that they're switching to using more proprietary main boards and PCBs. So it used to be that they used a lot of open source components, and if you had a main board go out, you could just get one on AliExpress for 20 bucks or so, maybe 40. But now Prusa is kind of the sole provider for replacement parts on this machine. As far as I know, the boards are, they're not manufactured by anyone else, so you have to get them through Prusa. And they probably have pretty good warranty support. Any issues that I had on my other Prusas when I was using them for work, I'd send an email to Prusa and they would get back to me within a day. And in one instance, I needed some replacement parts and they sent them over free of charge and got me back up and running again. So customer service from Prusa overall was very good. Also, there's two ways that you can buy this printer. You can either buy it as a kit for $800 or as a pre-assembled unit like what I have here for $1,100. And you also have to pay shipping on top of that, so it ends up being slightly more. Getting the pre-assembled is undeniably more convenient. I mean, I could just unbox this thing and start printing with it. But getting the kit printer isn't a bad idea either, because as you put this thing together and look at the 3D printed parts that they've designed, you get an idea of what you need to do to design parts for 3D printing. They use a lot of tricks in here to make things more printable and make them more compatible with the 3D printing process. Little things like using square nuts instead of hex nuts for integrated fasteners. You learn a lot of little tricks just seeing how they designed their 3D printed parts, and those are lessons that you can learn and apply in your own designs. Also, if you were to have some kind of issue where one of these parts broke, let's say you dropped something on it and it cracked it, well, you could just print out a replacement part and put it on there yourself. So that's one of the cool, unique little features of having a 3D printed 3D printer. But overall, why would you want to get this printer over some of the other competition that's similarly priced, namely cheaper Core XY machines coming out of China? Well, for starters, I think this printer is going to be more reliable because, I mean, just with my experience with Prusas in the past, they're generally more reliable than other printers. Also, the print quality is very good off of this machine. You can see these models where, it's laying line on top of line very accurately and precisely. And there's great documentation and customer support. So if you're using machines professionally and you want to minimize downtime and troubleshooting time, having that additional support and documentation is really nice. But your alternatives, if you're looking at this machine, you've got the Bambu Lab X1C, you've got the Creality K1 Max, there's the Cheatytech X Max 3, there's the FlashForge Adventure 5M Pro. I mean, these are all in a similar or less expensive price point than this machine, but they're offering that more advanced enclosed Core XY system that prints faster. Some of them offer better part cooling, and alternatives like the Bambu Lab X1C has flow compensation and a multi-material unit that's very good and has proven to be pretty reliable. Well, the main reason I would steer away from a Bambu Lab machine is because of their reliance on cloud features. I mean, using the Wi-Fi and setting that up on this machine was kind of annoying. But they have a really good offline workflow where you can print things over USB very easily, and that LAN mode printing is just running on your local network. So that presents a more secure workflow when you're handling sensitive models. Now, I've heard that you can run Bambu Lab printers in LAN mode and then you're not using the cloud, but there's still a closed source networking plugin that's, you're running a slicer on your computer and you're running a printer that can connect to the internet and is capable of communicating with the cloud servers. In those kind of cases, you can't really, rely on that as your security measures. Things could inadvertently be sent up to the Bambu Lab cloud, and you really have to have control over your models when you're working with sensitive or secret information. And that was the case when I was using these Prusa machines for the work that I was doing as an engineer. There were models that were related to certain industries that, have very strict requirements for cybersecurity, and unintentional exporting of those files would have been big trouble for myself and the company that I worked for. So that's the main reason why I would steer away from the Bambu Lab machines if I'm doing professional work, just because of the cybersecurity and cloud issues where, your models might be inadvertently exported to another country, and you really don't want that. The other reason why you might want to pick a Prusa over those other machines is having that enhanced support and documentation. If you're doing this type of stuff professionally, you don't want to be messing around with a multimeter with your machine all taken apart and having no one guiding you how to fix your machine. With these Prusa machines, support gets back to you quickly and they're able to help you fix your printer and get you back up and running because, you know, if you're doing professional work, you don't want to be wasting half a week just trying to figure out what's wrong with the printer so you can buy parts and fix it. You just want something that works. But to a lot of people, those won't be compelling enough reasons, and you know, that's why it's an open market and you can get whatever printer that you want. Overall, I will say that the user experience on this Prusa machine was quite nice and the print quality was very good. The one thing that I'd want to fix on here is the part cooling, but fortunately I know how to address that. I'll probably get some additional part cooling fans and install them on here. And with a new part cooling solution, I should be able to get up to 70 or 80 degree overhangs. So stay tuned for that if you want to see me mod this printer. But overall, I'm really glad that I got one of these MK4s in for review. It's one of those things where it's just really cool to be working with one of the higher end brands and something that's a little more expensive and premium. I'm still going to be doing a lot of content with my cheaper machines. I mean, I really like working with my Ender 3s and my Elegoo Neptunes, but there's just something about this printer that feels nice and premium, and it's just kind of a different design philosophy, and it's something that's a little more fun to use in my opinion. Now, if you don't have the budget for this machine, don't feel bad. There's plenty of other great options on the market that are less expensive than this. But if you want to get a Prusa MK4, I don't think you'll be disappointed with the print quality that you get. It'll be fun to take this machine apart a little bit and see some of the internal workings and get a new part cooling setup on here. So I'll probably be making a couple more videos about this machine. Let me know if you have any other questions about this Prusa MK4 or if there's anything else that you'd like to get a close-up of or like me to test out. But overall, I'd say I'd had a pretty good experience with this machine, and I could recommend getting one if you wanted something like this. Alright, well, thanks for watching this episode of Nathan Builds Robots, and I'll see you in the next one.